Okay. Yeah. So it's interesting how all of you are sitting on that side. Look, it's okay if you don't want to be in the camera. That's okay. But feel free to answer any questions because no one's going to recognise your voice. Probably only you will recognise your voice. So we're going to continue on from yesterday's lesson where we learned how to sketch the graphs of these circles. So I hope you can recognise what the picture of this is. Okay, so you can create, obviously now that you know how to sketch circles, you can create these eyes, but today you'll also be able to create a mouth as well. So we're also going to be learning how to sketch semicircles. In addition, what I've done is I've also drawn a horizontal line. So the equation of this horizontal line was y equals -1, and I've just set it for the x values between -5 and +5. So that's why it ends at those locations. I think I've shown you before how to restrict the x values that you showed. Later on in today's lesson, I may be able to show it to you again. Which means you should have your CAS with you today because I'll show you how to sketch these things on your CAS. I'm going to jump forward a slide. So here is what we're doing today. If you don't have your booklets out yet, can you please get them out so we're ready to continue? So this is 4D continued. We're going to explore how to convert the standard form of a circle's equation into the centre radius form. So a standard form of an equation could look something like this. Now I've written it there. It could be something that looks like x squared minus 2x plus y squared plus 4y plus 1 equals 0. And believe it or not, this is also the equation of the circle. The equation of the circle is actually the same as x minus 1 all squared plus y plus 2 all squared is equal to 4. So if you were paying attention to the lesson yesterday, you'd recognise that this is the equation of a circle, but that's also the exact same equation. So the first question for you, how do you think they went from this equation, the centre radius form, into that standard form? What have they done from here to there? Yeah, they've just expanded. You see all the brackets are gone, they've just expanded it. So what we're going to do first today is know how to go backwards. From this expanded form, which we call the standard form of a circle, how to go from here back to the centre radius form, where we can read out where the centre of the circle is and what the radius is as well. And the next part of today's lesson is to explore how to sketch semicircles. And by the end, we should know how to complete the square to form the centre radius form, and also recognise the equation of semicircles and sketch those semicircles as well. Have you all got your booklets out by now? Yeah? Okay, I'm just going to check that this is recording. Oops. It's not. Right. So the problem is, Chromecast doesn't work. Yes, right, let's move on. So, what I'm going to do today is I'll just show you how to go from the centre form to the standard form. Now we're going to investigate this question in a moment, but the first thing we're going to do, if there's any space near the top of your page, like somewhere here, I'm going to ask you to copy this down. So copy down x minus 1 all squared plus y plus 2 all squared is equal to 4. And what we're going to do is turn this into standard form. The standard form just means you don't have any brackets there, and everything's on one side of the equation with 0 on the other side. Have you all got this down? What you should notice that this is the exact same equation that we graphed yesterday. This was part of example 1. So let's go ahead. Let's go ahead and expand this. We expand these perfect squares. The first part is going to be, we have x squared, take away 2x plus 1. Right, what I'm doing here is just applying my perfect square formula. So that's for my first bracket. I'm going to colour code my other bracket as well. If you want to colour code, that's fine. Or just make sure you understand that this forms the second part. We have plus y squared plus 4y plus 4. And that was all equal to 4. So we expanded this to get rid of all the brackets. Now I'm going to collect everything to one side, And I'm also going to put the x squareds and y squareds together. So, the x squareds and y squareds, we have x squared plus y squared, right? Then the x's and y's, we've got negative 2x plus 4y. Okay, it looks a bit different from that, that's okay. And then we've got plus 1 plus 4, which is plus 5. I combine these constants together. And the last thing I'm going to do is make the other side 0 by subtracting 4, okay, minus 4. That's equal to 0. And then we can just combine these constants together. We have x squared plus y squared take away 2x plus 4y. Plus 1 is equal to 0. And we should label this the standard form. Jacob, can you close your Chromebook, please? Make sure it's closed. And I shouldn't be calling out students' names because of that. Okay. So this is called the standard form. Kind of like the standard form of a parabola, where you've got x squared, then x, then a constant. Do you all remember what the first line, what that form is called? I mentioned it just before, see if you remember. It's got to do with the center and the radius. So what form is it called? Yeah, it's a circle. It's the center radius form of the circle, because they give you the center and the radius. So this is center radius form. Now we're going to draw some arrows that take you from your center radius form to your standard form. So to go from this center radius form to the standard form, we expand. But to go backwards, what you need to understand is that we're creating these perfect squares. See, these perfect squares are created. These perfect squares, remember, they represent our horizontal shifts. So to take an algebraic expression and form a perfect square out of it, the process is called completing the square. Okay, so on the other arrow, we should write complete the square. And what you should notice is that once you can form a perfect square, like what we had in blue and in red, if you can form those perfect squares by completing the square, then you've basically got these brackets that come out. Okay, so that's what we're doing today, right off the bat. Now what they have here is just a proof, similar to what we did, that when you take a center radius form, is that the next line? So you should be able to see it here on this line. I don't think I copied it in. So what they've done is just the same as us, where they've expanded and they've collected the like terms. So the top line is the center radius form and the bottom line is the standard form. Now what we're going to do in this example is we're going to take this standard form and turn it into center radius form. Okay, that's what we're doing first. Now I'm going to rewrite this. In addition, year 11s, there's not going to be that much space at the bottom of your page. So if there's anywhere where you can link up that example down here, that would be great. When it got printed out, we didn't consider that this example needed a lot of space. Okay, so what I'm going to write, I'm going to rewrite that equation. We have x squared plus y squared minus 6x plus 4y minus 12 equals 0. Okay, so I'm going to complete the square. When I complete the square, there's two variables that I'm going to complete the square for. There's an x variable and there's also a y variable. So I'm going to be completing the square twice, once for each of these. So what we're going to do first is group the x's together, the x terms together, and group the y terms together. Okay, so that's the first thing to do. So we have x squared, take away 6x. That's the x terms, and the y terms are plus y squared plus 4y. And the remaining numbers are just constants. And they don't matter just yet. Okay, year 11s, do we remember how to complete the square? When we have these pair of terms with x squared and x, what's the next step? what do? It's really two steps in one. We take this number, then what? Half then square, exactly right. So we halve this number and we square it. What we get is x squared, take away 6x. Half of this number then squared gives us positive 9. And then we subtract the same number in order to not change our value. The first 3 terms is our perfect square, and we can factorize it into the perfect square. Same with the other one. We have plus y squared plus 4y. Then half then square, the 4. Half of 4 is 2, then squared is 4. Plus 4, then minus 4. And then the remaining terms carry down. Okay, so once you're at this point, you've basically completed the square. Now it's just about writing it in a perfect square form. So the first set of numbers becomes, when you factorize it, x minus 3 all squared. Reason being that 3, or negative 3 is the number that multiplies by itself to get positive 9 and adds to negative 6. The negative 9 stays behind. So the other side becomes plus y plus 2 all squared minus 4. And the remainders are minus 12 equals 0. So at this point, I hope you can see the center radius form coming out of the equation. And in fact, you could read off what the center is already. Now the last step is to combine all the constants together and just push it to the other side. So let's do that now. I'm just going to write it in black now. We have x minus 3 all squared plus y plus 2 all squared. I'm grouping these squared terms together. All the constants are negative 9, take away 4, take away 25 is minus 25. Is equal to 0. And it's x minus 3 all squared plus y plus 2 all squared is equal to 25. Okay, and here we've completed the square. Now at this point, your 11s, if you don't know how to complete the square, it's imperative that you learn. You need to learn how to do it. Okay, so I'm going to ask you now, can you identify where the center of the circle is? What are the coordinates of the center? Read it off here. Where's the center? 3, negative 2. Great, that's the h and that's the k value. So let's in fact write down where our center is. The center is at 3, negative 2. And we also know what the radius is. Is the radius 25? It's just 5, okay? Because that represents r squared. So r is just 5. So once you're at this point, it's basically the same as what we learned yesterday, how to sketch a circle. So if you weren't here yesterday, this is how we do it. Okay, we're going to sketch this. So let's sketch it out. What we'll need to do is figure out the intercepts as well, if there are any. But first what we're going to do is investigate where the circle is. So a little sketch somewhere near your page where you can label the center. The center has an x value of 3, 1, 2, 3, and a y value of negative 2, 1, 2. So that's the center. And what you should see right away is that because the radius is 5, 1, 2, 3, 4, 5 up there, and 5 down there as well, 1, 2, 3, 4, 5, then what's going to happen is that you're going to have 2 x-intercepts and 2 y-intercepts. Okay? We label the center first and use the radius to figure out the number of intercepts. So let's figure out the intercepts first before we sketch our graph. Y-intercept, let x equal 0. So I'm looking at this equation. What we get is negative 3 squared plus y plus 2 all squared is equal to 25. Then we can square the negative 3 and take it to the other side. That's 9 plus y plus 2 all squared is 25. So it's y plus 2 all squared is 16. Then y plus 2 has the solutions plus and minus 4. Keep in mind that when you take a square root, you get 2 solutions, and we can minus 2 from each of those solutions. Y becomes positive 4 take away 2, which is 2, or negative 4 take away 2, which is negative 6. And that confirms what we saw earlier. We should have 2 y-intercepts. So at this point, we're going to figure out the x-intercepts. Let me see. How about this? I'll give you a couple minutes to try and find the x-intercepts yourself, and then I'll put the answers on board. Figure out the x-intercepts now. You want to turn it off? Have you done it? Thank you. You're doing it all in your head. That's impressive. We can get you marks though.
Yeah.
Right, so I'll quickly put the working out on the board now. I'll do that in a different colour. So x-intercept, we make y0. So same equation, x minus 3 squared, plus, no y's, because that's 0, plus 2 squared is equal to 25. I square the 2, then I subtract it, we get x minus 3 all squared is equal to 21. Since 21 is not a perfect square, when I square root it, I can't simplify. So we have x minus 3 is equal to plus or minus root 21. And then I add 3 to both sides. 3 plus or minus root 21. So 2 x-intercepts and 2 y-intercepts. Now, I hope you still have some room in your page because we're going to sketch the graph now. So let's sketch the graph. We start off by understanding that most of our circle is in quadrant 4, so I'm going to put a point, so I'm going to sketch my graph with most of it in quadrant 4. In addition, and this is quite important, where you place your center is also quite important. Because your radius is 5, if I put my center too close to the edge, my circle is going to fall off my graph. Okay, so you've got to be mindful of where you put your center. I'm going to put it a bit more to the center than I normally would. So where would that be? The center is 3, negative 2. So I've got 1, 2, 3, then 1, 2. So that's my center, 3, negative 2. The next thing I'll do is I'll place the edges of my circles by looking at the radius. So I know my radius goes by 5 units in all directions. So it's another 1, 2, 3, 4, 5. The circle's going to be here. Then 1, 2, 3, 4, 5. The circle's here as well. If you're not accurate with your scale, it just means your circle looks more like an oval, but that's still okay. And it should be a bit more. 5 up, 1, 2, 3, 4, 5. Up here, then 1, 2, 3, 4, 5, and it's down here. I think my circle's going to turn out looking more like an oval. That's okay. So let's sketch our graph through those points. And the last thing to do is just label where the intercepts are. So what we have are the y-intercepts of 2 and negative 6. It's okay if your circle doesn't lie exactly on your markings, because we're not perfect at sketching circles. Then we also have 3 plus root 21.
Mr. Zhu,
Yeah.
you labeled it as a negative 2. Wow.
Oops, my mistake. Yeah, so it is positive 2, not negative 2. Thank you for picking that up. And it does turn out that if you do label it wrong, even if you write it correct here, but label it wrong on your graph, you don't get marks for that part. Okay, so you've got to be really, really careful, like I should have been. And the last one is, on the other side, 3 take away root 21. Okay, and we've sketched our circle. Now, on a test, this shouldn't take more than about 6 minutes. Okay, 2 minutes for this part, you'll get 2 marks for 2 minutes, and about 4 marks for the graph. Now, in total, 6 minutes. You'd probably be spending most of your time on here, and less of your time on there. Okay, 6 minutes for this. All right, so we've covered that part. Just remember, please, to go from your standard form to your center radius form, you complete the square. I'm going to rub this off now, is that okay? I'm going to rub this off. So we're up to the next part of our lesson, which is on semicircles. And I'll invite you to turn your page to the other side. So we introduced semicircles from the equation of our circle. So this is the mother function of a circle. And we investigate what happens when we try and solve for x or solve for y. So what they do first is they solve for y first. It's already on there, so you don't have to copy it down. But this is what you get. 1 minus x squared by subtracting x squared on both sides. And then y has the solutions of plus or minus the square root of 1 minus x squared. So let's interpret what this means. Do you all agree that the first line represents the equation of a circle? Yeah, are we happy with that? Now if I move the x squared to the other side, is it still the same circle? Is it still the same equation? It looks different, but does it still represent the same thing? Okay, so it's still got to be the equation of a circle. Now what happens here when you take the square root is you've got two versions of it, a positive version and a negative version. Now this circle is still a circle that's centered at the center, and it's got a radius of 1. But what they've done here is they've separated it to its positive and negative versions. The top part represents y is equal to plus root 1 minus x squared. Okay, that's the top semicircle. And the bottom semicircle, do we agree? The bottom semicircle is y equals minus root 1 minus x squared. By taking the square root, you split up your circle into two parts. The positive part for all of your positive y values, okay? All the positive y values, and here we have all the negative y values. Alright, so that's literally what they've got here as well. And I think instead of using 1, they use r. So in fact, I could have used the radius as well. So it's r squared, r squared, r squared, and all of these are r squared. Okay, so what I'll show is also the other version of a square root as well, because the other thing you could also do is solve for x. Here we solve for y. By solving for y, we get our top and the bottom of semicircles. If we solve for x, this is what we get. X squared is equal to r squared minus y squared. Okay, looking from our top line to this line, what I've done is I've subtracted y squared from both sides, and then I take the square root. X is equal to the plus or minus of r squared minus y squared. I'm going to ask you to have a look at this carefully for a moment. What do you think, what types of semicircles do you think this represents? Sideways, okay? Sideways semicircles, because instead of y's being positive or negative, now it's the x's being positive on that side or negative on this side. So here's what we get, a semicircle where on the positive side you have no longer x, no longer y. X is equal to the positive version of r squared minus y squared. And on the other side you have x is equal to the negative version of r squared minus y squared. So we get 4 different types of semicircles. The way I remember this, here's the way I remember. First, I look for the form. If it's got a square root and a number squared minus a squared variable, then it's got to be a semicircle. Okay, that's the first thing I think. Then to determine whether it's like that semicircle or this or that, then I'll look at whether it's got to do with x's or y's. If it's got to do with y's, then it's got to be a one that's upwards or downwards. If it's got to be x's, then it's ones that are going sideways. And if it's an x with a negative, then it's got to be on the negative side. Right, so at this point, I'm going to ask you to take a few extra notes down. Where it says on your page, this, can you all locate these two equations on your page? Yeah, it's about here. So what you should do is draw a corresponding diagram. So for this, it's the top half, and y is positive. For this next one, it's the bottom half. Y is negative. Now I'm sorry, I'm going to turn on the aircon because it's getting warm here. Sorry, I'm in. Okay, Year 11s, have you all got this down? Alright, so remember, when you see an equation like this, you've got to recognise what it looks like. If it has a y at the front, then it's got to be a semicircle, top half and bottom half. Now, at the bottom, where you've got these two equations, please locate them where they are, about here. You might have to draw them separately, write these equations separately, but when you do, so you're going to write something like this, and this is going to be the semicircle that's on the negative side of x, negative x, and we've got a positive version as well, r squared minus y squared. Positive x. I'm going to rub this off the board. Okay, so quick question. I want you to tell me whether it's the top half, bottom half, left half, or right half. Right half. Okay. Look carefully. We have y is equal to the negative square root of 4 minus x squared. Bottom half. Good. So this is something like that. In fact, when you do actually have a question like this, what the first thing you do is sketch a little graph first. Another one. X is equal to the square root of 1 minus x squared. Right, okay, it's got to be on the right. It's the positive x times. One more. Y is equal to the square root of x. It's not a semicircle. It's a square root graph. So I've tricked you there. It's a square root. Okay, remember our square root graphs? It looks like this. Yeah. Yeah, it would be a 1 squared, but the fact is,
Wouldn't it be a y squared?
a y squared, here, yeah, yeah.
See, I've got x squared.
Oh, you're at x twice.
Oh, oops, yeah, sorry. Thank you for pointing it out. If it was x squared, then it wouldn't actually be a graph that you can draw, because in order to have a graph, you need to have a combination of x and y. Okay, thanks for pointing that out. Now I'm going to move on. We'll do some examples on sketching semicircles, and then I'll show you how to sketch all these on your CAS. Right, are we all on this part? It should be near the bottom of the page. So let's recognise this. Please tell me, is it top half, bottom half, left half or right half? Top half, okay, we're going to draw a little semicircle. I'm sorry. Do you recognise what the radius is? Well, the radius is 2, because of our equation. For the top half of a semicircle, that first number there, that's always the squared value of the radius. So if they've already squared it, you need to unsquare it. So let's write this down. R is equal to 2. Now, in this case, there's no translations. In a couple of examples later, we're going to show you what happens to the translations. But let's write the centre as 0, 0. So this should be pretty easy to graph. The centre's at 0, 0, and the radius is at 2. So here's my centre, 0, 0. It goes 2 to the left, 2 to the right, then 2 to the up. If your scales aren't exactly the same, then it might look more like an oval. But try to make it look like a semicircle. And the last thing to do, obviously, is to figure out what the intercepts are. So the intercepts for this, it should be easy to get as well, because it just goes 2 units from the centre. We've got 0, 2, 2, 0, and negative 2, 0. Do you think you can try the second example? Like, before you try, which side? Top, bottom, left or right? Left. To the left? Okay, so draw a little semicircle, then try this yourself. also be sure to label any intercepts. If a point does touch the intercept without going through, it's also known as an intercept. Is this what you all got? Yeah? All good? Okay. So let's move on. I'm going to do the remainder of the examples on the board to the right. Reason being, I want to show you some CAD stuff in a moment, if we've got time. Okay, so what you should see here is also a semicircle, but it's a semicircle that's being translated, it's being shifted. So I'll briefly describe how that represents a shift. Now, if you want to copy this extra stuff down, you can choose to. Now, do you have space? Yeah, you have a lot of space. So if you want to copy it down, you can. But this is where you get your general equations of semicircles. If you want to copy this down, semicircle equations, including all the horizontal or vertical shifts as well. So we have x minus h all squared plus y minus k all squared is equal to r squared. And now what we're going to do is solve for y, including all of those h's and k's. Okay, let's solve for y. First, I remove the term that's got to do with the x's to the other side. So I subtract it on both sides. Once I get to this point, I undo the square by taking the square root, but we've got two versions, a plus and a minus version. So it's y minus k is equal to plus or minus r squared minus x minus h all squared. Now you should be able to see something that looks like what's in the question. And the last thing to do is add k to both sides. Y is equal to plus or minus the square root of r squared minus x minus h all squared plus k. Now keep in mind that plus or minus part, that has to do with the top and the bottom halves of your semicircles. But all these other numbers here, the h's and the k's, they still represent horizontal or vertical translations. So that's how we read it off this graph. Now once you finish copying it down, I'm going to ask you some questions. First question, what is the radius? 7? Okay, radius 7. Now you've got to think about how the graph is being translated. Firstly, look at this constant number. Is it going upwards or downwards? Downwards, okay, it's going downwards. It's not sitting next to the y anymore, so we just follow it down. It goes downwards by 2. Is this going to the left or the right? Left or right? Right, okay. It sits with the x, so it goes in the opposite direction. So, it goes to the right by 2, but it goes down by 2. So the centre is 2, negative 2. It should be pretty obvious that if your centre's at 2, negative 2 and the radius is 7, then you're going to get some intercepts. So let's start by finding the intercepts. What we're going to get is, actually, here's the case. You're going to have one y-intercept instead of 2. So like before, we should probably sketch what this is going to probably look like, and then figure out where the intercepts are. So do a little sketch of a graph where the x is 2 and the y is negative 2, roughly here. And the graph is going to be a positive y facing a semicircle. Okay, so how many x-intercepts do we have? 2. And y's? 1. Okay, 2 x-intercepts and y. 1 y. Let's find the x-intercepts first. X-intercept y is 0. So 0 is equal to negative 2 plus the square root of 49. Take away x minus 2 all squared. I don't get a chance to show you the CAS, then what I'll do is I'll upload a lesson where I do the CAS, because it's pretty easy with the software on the computer. And I'll ask you to follow that video as well. I'll add 2 to the other side. 2 is equal to the square root of 49. Take away x minus 12 squared. Then I'm going to square both sides to get rid of the square root. 4 is equal to 49. Take away x minus 2 all squared. Subtract 49 to both sides. What we should get is negative 45 is equal to negative x minus 2 all squared. Then I'm going to do 2 steps at once. First, remove the negatives, then take the square root. X minus 2 is equal to plus or minus root 45. Then I'll do 2 steps up once again. Because there's a square factor in here, which is 9. 9 times 5. I'm going to simplify the third. So it's x is equal to 2 plus or minus 3 root 5. And that shows we've got 2 x intercepts. Next one, we figure out our y-intercepts. X equals 0, y is equal to negative 2 plus the square root of 49, take away 0 minus 2 all squared. So let's follow our BODMAS. It's minus 2 plus the square root of, this is positive 4 and it's 49 take away 4, which is 45. And I can simplify that to negative 2 plus 3 root 5. Okay, and we notice we only get one solution for y, and the graph we drew earlier confirms that. So let's sketch this now. We've got all of the information, including the center and the radius, and the fact it's also an upwards facing graph. Since it's mostly in quadrant 4, I'm going to leave more room in quadrant 4. Oops. Here. The radius is 7, so I'm not going to go too far out. So the center is at 2, 1, 2. Goes down by 2 as well, 1, 2. Then I'm going to start by going my radius. 1, 2, 3, 4, 5, 6, 7. So it ends there. 1, 2, 3, 4, 5, 6, 7, and it ends here. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7. Down here.
Wait, why are we drawing 4?
Ah, good question. That's my mistake. Yeah, it's not a full circle, it's a semicircle, so it's just the top half. Thank you for pointing that out. So it's the top part of a semicircle. Let's join these up. It was intentional, to see if you're paying attention. Okay, let's put all of our points in. The x-intercepts 2 minus root 3, 3 times root 5. So it's 2 minus 3 root 5. And also 2 plus 3 root 5. And our y-intercept as well, which is negative 2 plus 3 root 5. So it's 0, negative 2 plus 3 root 5. Now the key takeaway from this lesson, apart from recognizing the equations of circles, is to recognize the equations of semicircles. Whenever you have a square root and also a variable inside that's being squared, it's most likely a semicircle. So the next part is to identify whether it's the top half, bottom half, left, right, and if there's any translations to its center and what the radius is. And apart from that, finding the x and y intercepts is just algebra. Okay, I think there's a bit of time. In the next 5 minutes, I'll show you how to do this with your CAS, and then I'll rely on you to do the rest for homework. I'm going to rub off all this. So please get your CAS out. We've got about, actually more than 5 minutes, we've got about 10 minutes. So let's spend a bit of time on this. Okay, so here's my picture of a crown, and notice I've put a slider in here, so you can freely move the eye, right and left. That was funnier to me. So let's open a new document. And the problem with sketching circles is the fact that your y isn't sitting by itself. With all the previous graphs that you've sketched, y was always sitting by itself, so you only had to sketch the other side. So let's open up a new graph. And we need to find a way of entering an equation where it's not just x's on one side. Right? You're gonna close that Chromebook code? Okay. So here's how to sketch relations. The graph of a circle is not called a function, it's called a relation for reasons you'll learn later. So we can't use this function tab that's represented with F. So the way we do it, look carefully, it's through menu, then graph entry, menu, then graph entry, okay? Menu, then graph entry, then which one of these options do you think relates to circles? Which one? Okay, number 2, because it looks like a circle. So let's go down to 2. And which one of these is actually the option for a circle? 2. 3. So it's 3. Why is it different?
Wait,
Really
I
should
said
go through the
relation.
same thing.
Ah, okay. So I'm going to ask you, yeah, that's right. So on yours it might look different, but just follow the words, okay? So we go to graph entry, then equation. You all have that equation on yours?
Yeah.
Then go to circle. And then it gives you the 2 different forms. Remember, we've got the center radius form and the standard form. So what we're going to sketch are both. Let's sketch both of these in. First we're going to sketch x minus 1 all squared plus y plus 2 all squared is equal to 4. And the nice thing about this is, because we did this as an example, this is a quick way for us to check our answer. So let's enter it there. And there's places where we can enter our values. So our equation's there. We've got x minus 1 all squared. So what number should we enter in this box?
1.
1? Okay, good. So we get x minus 1. In the next box, we should end up with y plus 2. So what number should we add there? Negative 2. So it becomes y plus 2. Then it's equal to 4. And we press enter. 2. Yes, my mistake. So we get 2 squared, that's equal to 4. We press enter. Can you check that this becomes your circle? Yeah, is yours correct?
Yes.
Right. So I'm going to ask you to navigate to the other one, it's the standard form, and sketch this one in.
In the same graph?
Yeah, on the same graph. Now the problem is, what you should notice is that nothing should change because they both represent the same circle. So let's check if that's the case. Menu, graph entry, equation, then circle, then standard form. Menu, graph entry, equation, circle, then standard form. So now they're going to ask you to enter all of the coefficients. If there's no coefficient of x squared, what can you enter? 1? Okay, let's enter that. So we've got 1. Then for the x coefficient, we've got negative 2. And for the y coefficient, we've got 4, and the constant is 1. Now you should press enter, and you should get the same circle as before. Yeah, do you all get it? Okay, and the reason why it's the same circle is because they're the same equation. This one is where you've taken the second line and you've completed the square, and the second one is where you've taken the first line and you've expanded it. So it should be the same. Now, let's understand how we go back to entering functions normally. Okay, because now I'm going to ask you to press tab. Press tab. And when you press tab, this annoying thing comes out. So the way you get back to your previous functions, I'm going to ask you to press escape now to get rid of that if you got it up, is to go through menu, then graph entry, then function. When you press that, this is going to bring your functions template back up. Okay, that's how you always get back to it. So once you enter an equation and then you want to bring it up again, you press tab and it comes back to the original thing. Now, if you want to delete equations, what you can actually do is hover your cursor over it, then right-click. Right-click is control menu, and you can delete the relation. Okay? And that's something you can do. So right-click on here is control menu. It's not coming up. Have you hovered your cursor over the circle? Press Control, then press Menu, then it right clicks. Are you all able to do that?
Yeah.
So hover your cursor over the circle until it becomes bolded. Press Control Menu, and go down to if you want to edit the relation, change it to a different form, you can. Or if you want to delete it, you press Delete. Now, delete's the second function that you do. You have to do it again if you want to delete the last one. Okay, so we've finished our lesson for today, and we've covered both of our success criteria. I'll rely on all of you to do as much as you can. It's not ideal when you don't have time in class to do work, but I'll try and give you time next week. Yeah, question?
If you hold down the delete button, doesn't it just delete everything?
Does it?
Yeah, if you hold it down for 2 seconds, it brings out. You sure you want to?
Oh, interesting. Hey, you're Evans. Try this. Thanks, Aaron. If you're on this graph, if you press and hold delete, it'll ask you if you want to delete everything and anything. Anything or everything.
Everything.
Everything, okay? So once you press that, I think it takes you back to a blank page. Okay? Right. So that's something new I've learned today as well. Now the bell's going to go in 2 minutes. You can start packing things up.
What? No.
Adam, control.